Hello everyone, and welcome to Unit 2. This is Lesson 17, Systems of Linear Equations and Their Solutions. So they're starting out in 17.1 a curious system. You have these two equations. And they go on, they kind of start you out here. They say, look at the first equation. He thought the solution system is a pair of numbers that add up to 3. I wonder which two numbers they are. Okay? So, you could think of, if you have a system of equations, you could think of them as, you could have like, 1 plus 2 equals 3. You could have negative 1 plus 4 equals 3. Negative 2 plus 5 equals 3. Okay, this kind of stuff, all right? You could have, of course, 2 plus 1 equals 3. And, it goes along back and forth like this. So you have a series of numbers that you can go and bounce back and forth to add up to 3, which is essentially this very first equation here. And then you look at the second equation, and it's kind of fishy. So if we look at what they're trying to ask here, choose two numbers that add up to 3. The pair of values you choose is the solution for the first. Check and see if it's the solution for the second. Well, if you put that in, if you put in 2 and 1, 4 times 2 is 8. And then 12 minus 4 times 1, that's 4. So 12 minus 4 is 8. And look at 1 and 2. 4 times 1 is 4. And if you put in a 2, then it's going to be, if you put in a 2, it's going to be 12 minus 8. And so it just keeps going that way. I mean, it just, no matter what combination you come up with, if it works in one, it works in the other. Well, the idea here is these are exactly the two same equations. Let's do a little bit of magic. Let's see if I can go from one and come to the other. X plus y equals 3. Well, let's start out by moving the y. Okay, so I'm going to subtract y from both sides. So x equals 3 minus y. Alright, so I just moved the y from one side over to the other. And now let's go and take this thing and just multiply both sides by 4. What's 4 times x? Well, that's 4x. 4 times 3 is 12, and 4 times a minus y is a minus 4y. Well, as you can see, this one and this one are the exact same equation. These are the two exact same equations. I just manipulated very simply to get from one to the other. So that's what's going on here. How many solutions does the system have? It has an infinite set of solutions because both of these represent the same equation. This is a line, and it goes through 0, 3 right there, and it also goes through 3, 0, which is right there. All right, and so if you go 2, 1, or 1, 2, or 2, 1, these are all on the same line. Alright, so you can actually start drawing a system of lines here, dots, and you just connect them, and turns out there's an infinite number of solutions for this problem. It's a line. Okay, so that's what's going on there, and they just restated it with this second one. That's all what they're doing. So the question is, what's the deal? A recreation center is offering special prices on its pool passes and gym memberships for the summer. On the first day of the offering, this family paid $96 for 4 pool passes and 2 gym memberships. Later that day, an individual bought a pool pass itself and a pool pass for a friend and 1 gym membership. She paid $72. Write system equations for this relationship between pool passes, gym memberships, and costs. Let's see, explain your reasoning. Use graphing technology to graph them. Okay, so we can go through this. It's pretty basic here. So let's just read this in. On the first day of the offering, a family paid $96 for 4 pool passes. So we can write that as $96 times 4 pool passes. Alright? And it goes on. Let's see. And 2 gym memberships. 4 pool passes and 2 gym memberships. All right. So we don't know how much the gym membership is. And we don't know how much the pool membership is. But we know that for to start out with, they paid $96. Right? They got 4 pool passes and 2 gyms, and they paid $96. Later that day, an individual bought a pool pass for herself and a pool pass, so 2 pool passes, so 2P, 2 pool passes and 1 gym membership plus 1G, and that came up to a total of $72. Okay, so here's your system equations: 4 pool passes plus 2 gym memberships, $96. 2 pool passes plus 1 gym membership, $72. Okay, so let's go back to our equation and see what they want here. Find the price of the pool pass and the price for the gym membership by solving the system algebraically. Explain your reasoning. Okay, so if we look at this thing, let's go and look at our equations here. We got a couple different ways. You know, we have elimination and substitution on how to solve this. I'm going to use elimination. It's just easiest. Let's take this bottom one and just simply multiply it by 2. Let's see what we get. All right. So if I take the bottom one here and I multiply it by 2, what do I get? Well, what's 2p? 2p times 2 is going to be a 4p. And then 2 times 1 is 2g. And then what happens here? What's 2 times 72? Well, 144. So what happens up here? I still have the 4p. I still have the 2g. All right, and I have 96. Well, what problem do you see here? You got 4p and you got 2g's and you got 96 and 144. All right, these same numbers over here, no matter what numbers you put in, you get the same number. Well, does it equal 96 or 144? All right. Well, the answer is there a solution? In other words, is there a place where they both meet? And the answer is no. What does this look like? Well, let's go and look at these 2 equations. Okay. Your first equation was 4p plus 2g equals 96. All right. What's your other one? 2p plus 1g equals 144. All right. What is this? Well, let's do our old thing here. Let's find the slope and the y-intercept. Okay. Well, what's the slope going to be? Well, it's going to be a negative a divided by b. Well, that's your slope. So that's a negative 4 divided by 2, which is a negative 2. What about this one? Well, I got a negative 2 divided by 1, which is a negative 2. They both have the same slope, which means that they are parallel. Okay. Now let's try to find the y-intercepts. So if I do that, I'll put the p's down here for pool pass. I'll put the g's here for gym memberships. All right. So if I put in a 0 in each, 0 plus, if I do a 0 here, that's just 1g equals 144. So it starts at 144. So it goes through 0, 144. And if I put a 0 into here, that's a 0. 2g equals 96. Well, if 2g equals 96, you divide both sides by 2, g equals 48. So it goes through 0, 48. Let's go down here. 0, 48. Now they both have a slope of negative 2, so what does that look like? Looks like this. They're parallel. Are they ever going to cross and have a solution? No. That's what happens. You can always tell if 2 standard forms are parallel if they have the same slopes. And all you've done is you just change this last little value. You can move this thing up and down. That's all you did. Okay. So that's the thing that's going on in that first problem. All right. Teacher will set of cards. All right, 1, 0, infinitely many. Okay, here's an equation. Create a second equation that will make the system of equations with one solution, no solutions, infinite solutions. All right, so this is what you got going on here. When you have two equations, when you have two equations, okay, you have no solutions, you have one solution, and you have infinite solutions. All right? If there's no solutions, that means they're parallel. That's all there is. That means they're parallel. Okay? They don't have any solutions because they're basically they're parallel. They'll never meet. They'll never be a solution. Never. One solution, all right? And what you do is you have a couple ways to find that. You have elimination, or you have substitution. Okay? And that looks something like this. You have the solution right there. Right? Two different slopes. So over here they're parallel, so slope for one equals the slope for the other. Here the slope of 1 does not equal the slope of 2. Okay? Infinite solutions means that the two are one on top of the other. So they're basically just multiples of each other. So line 1 is a multiple of line 2. That's what's going on. Right? And of course, if it's the same equation, then the two slopes are the same. All right? Whereas here, the y-intercepts are different. So you got intercept here and intercept here. Y-intercepts different. Over here, y-intercept's the same because it's the exact same equation. Okay, so that's what's going on here. You either parallel, which have the same slopes. You can either have no solutions or an infinite number of solutions. If their intercepts, the y-intercepts are different, then you're going to have parallel and you'll have no solutions. If they have the same slope and the y-intercepts are also the same, then they lie right on top of each other. It's only when they have different slopes we will actually get a two lines and thus one solution. That's the whole deal of what's going on here. So let's look at this equation here. 5x minus 2y equals 10. Okay, so I want to get one that's parallel with no solutions like this. So I'll call this situation 1. Okay, so situation 1. I'll get it with one solution. I'll show you how to do that. All right? And that's situation 2. And then situation 3 is an infinite number of solutions. So I'll go through that. Okay, so we're starting with the same equation. So what are we being asked to do? Find one with one solution, no solutions, infinite. Well, I'm going to go no solution, and then one solution, and then infinite. All right? So let's do that one. No solutions. Okay, no solutions. Let's try that one. Okay, so I'm going to try it with this equation here. What do I got to do that? Okay, well, if I want no solutions, I have to have the exact same slope. Just have to change the y-intercept. Here's the easy way. So here's situation 1. No solutions. (5x minus 2y). There. I got the slopes. Slopes are the same. Same ratio between the a and the b. And I'm going to have no solution. So rather than 10, I'll make it 11. Just any other number, but not 10. All right? Not 10. Okay? If I want to have an infinite number of solutions, I want them to lie right on top of each other. There's situation 3. I'm going to have 5x minus 2y equals 10. I just have to have a multiple of that exact same thing. So I'll just multiply by 2. 10x minus 4y equals 20. There. They have the same y-intercept and the same slope. Let's look at the slope. What is slope? Negative a divided by b. That's a negative 10 divided by a minus 4, which is 10/4, or 5/2. What's this slope? What's this slope? Negative a. that's a negative 5, divided by b, which is the negative 2, 5 halves. Oh look, same slope. And since it's just a multiple of the original, it's going to be the exact same line. Okay? So there's 3, there's 1, here's 2. You want one with one solution? Real simple. Just swap the a and the b. There. Done. What's the slope on this one? Slope equals a minus negative 2 divided by 5, which turns out to be 2/5. There. 5 halves up here, 2/5 down here, different slope. So if it's two different slopes, it's got to have one solution. So that's the basics on that one. Okay? Quick little manipulations that you can do. So here's your summary. Let's look at these 3 systems of equations. So here's your 2 equations. All right? What's the only thing different here? You got a 3, you got a 4, you got an 8, plus here, minus here. Okay? So what's happening? Well, if you look at these things, one produces a negative slope, one produces a positive slope. So this little bottom one here is blue, and this little top one here is the one in black, right there. Right? They're both going through this little point, the point of intersection. All right? And that looks like about, I'd say 8/3, comma 0. All right? And so the system equations intersect at one point. Here's the other one. This is the one with infinite number of solutions. If you go from here to here, they have the same slopes, and they're just essentially multiples of each other. Take this top one, multiply by 2, and you get these exactly the same here in the bottom. Parallel, what'd you do? These are essentially the same. All you did was change this last 4. The 8 one is right up here on top. This bottom one is down here. All right? So that's what's going on there. That's all it is. And it kind of tells you what's going on within each instance here. So that's all there is to it. And we can tell without graphing system 2 any solutions. All right? System 2, any solutions? Well, there's one right on top of each other. They have an infinite number of solutions. Rearranging this one in slope form. All right, you can put this, take this one right here, you can go and manipulate to put into the y-intercept form. Slope is negative 3/4, it goes through 0, comma 2. And you take this one, and you get the same exact equation. All right, both lines have the same slope and the y value of the vertical intercept. So, and it goes on to explain a little bit more down here. So that's basically what's going on there. That's the 3 things that you can have when you have 2 lines on graph. They could intersect at one spot, but only if they have different slopes. If they have the same slope, then they can have no solutions or an infinite number of solutions. Okay, and that's all there is with that today. We're going to be going in and exploring this a little bit more as we go along. And that's all that I have for today. Thank you.